So we took a break from the skeletal system while we did neurophysiology, sorry, and muscle physiology. But we're going to finish up the skeletal system now. So let's review just a little bit. Remember we said the skeletal system was more than just bones. It was cartilages, it was bones, but it's also joints. So we've already looked at cartilages and bones. So what we're going to do today is we're going to talk about joints. So joints are technically called articulations. So the word articulation means to come together. And that's what a joint does. It's where things come together. So it could be where a bone comes together and meets a bone, but it could also be where bone meets cartilage, or it could be also where bone meets tooth. Well, if you think about why we have joints, joints are all about movement. So if we didn't have any joints, if you just had one solid bone as your skeleton, it would be very, very strong. It would be very, very supportive and all those things. But there would be no movement because movement happens at the joints. And so the primary function of joints is to give the skeleton mobility. But a secondary function is it has to hold the skeleton together because when you have a joint, you're going to have a separation of bones. And so you have to hold them together, or at least in close proximity. And so another function is to provide stability for the skeleton. So two functions, mobility and stability. Well, just like we've done a bunch of times before with other systems, we're going to classify joints. And remember, this is anatomy and physiology, so there's going to be two ways to classify joints. One is an anatomical way. And remember, anatomical is all about structure. And so when you look at a joint and you see what's there, what the structure is, that's an anatomical classification. And there are three of these. There are fibrous joints, there are cartilaginous joints, and there are synovial joints. But there's another way to classify them too, and that's based on physiology. Remember, physiology is about function, and the main function is mobility. So a physiological classification is based on how much movement there is at each joint. And again, we're going to have three. We're going to have synarthroses, amphiarthroses, and diarthroses. Arthro means joint, like an arthropod. So when you see arthro anywhere, it's referring to a joint. So let's look at these. So here is a flow chart just to show you these classification systems. Again, anatomical, 3, fibrous, cartilaginous, synovial. Physiological, 3, synarthrotic, amphiarthrotic, and diarthrotic. Well, you can classify every single joint in your body both ways. If you just randomly pick the joint, if you just pick the shoulder joint, well, the shoulder joint, when you look at it, it's a synovial joint. And we'll talk about what makes it a synovial joint later on. But then think about how much movement there is associated at the shoulder. Well, the shoulder is very movable, and the word for very movable is diarthrotic. So the shoulder is synovial and diarthrotic. And you can go through with that with any joint in your body, the shoulder, the knee, the hip, the fingers, the sutures, the joints at your teeth. All of these can be classified both ways. Well, we have to pick one way or the other to classify joints, to talk about them. And since the book uses the anatomical classification, that's the one we're going to use too. So remember, there are three types of joints based on this anatomical classification. There are fibrous joints, cartilaginous joints, and synovial joints. They're all different from each other. Fibrous joints, the bones are right up next to each other. They're like this. They're very close. And they're tiny little fibers that are holding the bones together. And we're going to see these little fibers. So fibers, fibrous joints. If you look at a cartilaginous joint, again, the bones are pretty close to each other. They're right up next to each other. But what's holding them together is not fibers, it's cartilage. So there's cartilage in between the bones like this. There's no space, no cavity, just cartilage. But if you look at a synovial joints, the bones don't actually touch. So here's one bone here, and there's not another bone till over here somewhere. And there's a space between them, a cavity. And so when you have this cavity, it gives you a lot more mobility. But look, there's something protecting the joint. There's something holding it close together, but the bones don't actually touch. There's a space, a cavity in between. So let's look at these three types of joints. So fibrous, cartilaginous, and synovial. There's this other way of classifying joints too, and this is again based on movement. So some joints don't move at all. There's no movement whatsoever. They're immovable. Those are called synarthroses. There's some joints that are slightly movable. In other words, they just sort of wiggle a little bit. Those are called amphiarthroses. And then most of our joints have lots of movement. They're freely movable. And freely movable joints are diarthrotic. So remember I said if we looked at the shoulder, if I look at it under just with my eyes, I see that the bones don't actually touch each other. There's a space between the bones. And since there's a space, it has to be a synovial joint. And then if you think about how much movement there is at the shoulder, there's lots of movement at the shoulder. And since there's lots of movement, it is diarthrotic. So it's a synovial joint and it's diarthrotic. Again, you can do that with any joint in the body. So there's our three classifications based on movement. Well, even though you can classify all joints both ways, we're going to have to pick one in order to just talk about it, but we'll come back and talk about the other one. The one we're going to pick is anatomical because, like I said, that's what the book uses. So let's look at these joints. So with anatomical classifications, remember we have fibrous, we have cartilaginous, and we have synovial. So let's look at the fibrous joints first. So there are three different types of fibrous joints. There are sutures, there are syndesmoses, and there are gomphoses. Well, sutures are already pretty familiar to us because we learned them, some of them, when we learned the skull. Remember, that's a suture. That's the coronal suture. That's a suture. That's the sagittal suture. That's a suture. That's the lambdoidal suture. And so when we look at the sutures, we're going to see little fibers holding the bones together. Same thing's true for a syndesmosis. We're going to see fibers holding the bones together. And the same thing's true for a gomphosis, which is at your teeth. And again, we're going to see fibers holding the bones together, or the tooth and bone together. They're all fibrous joints. Let's look at sutures first. The only place in your whole body where you have sutures is in the skull. And there are over 100 sutures in the skull. We only learned 4. We only learned 4 of them, but every 2 bones in the skull has a suture between it. And if you look at the suture, again, they look like this. They have these interlocking bones. So here's one bone here, and here's another bone here. And they have these sort of interlocking kind of things, like putting your fingers together. But if you look inside there, what you're going to see are little tiny fibers holding those bones in that place. You remember the adult skull? The adult skull, those interlocking joints are very, very tight. And so in the adult, sutures are synarthrotic. But remember we looked at a fetal skull similar to a small child. And remember we had those things called fontanelles, those soft spots. And what fontanelles do, they allow the skull to move a little bit. And so in growing children, there is a little bit of movement. And so they're amphiarthrotic. So if you look at the difference between an adult skull and an infant, here's an infant here. And again, you can see these soft spots. Well, what that is the bone has not grown together. If you look at it in an adult, this is going to grow this way and this is going to grow this way. We get this interlocking suture. But the sutures here have not met. They've not form these interlocking junctions. And so the head of an infant is malleable. And so if you've ever seen a baby right after it's been born, their heads are not shaped like adults are. Look, they're sort of cone shaped. And the reason they're cone shaped is because they've been pushed through the birth canal. But usually after about 24 hours, they go back to this more rounded appearance that we would expect. But they don't have to. You may have seen babies wearing helmets. Those helmets sometimes are to correct this. They're to bring it back to this round position. But what if you didn't want it to be round? You can actually force the skull into this position and keep it that way. And that's exactly what happens in some cultures. And so some cultures intentionally deform the skull. And so they cause this flattening of the forehead. And if you look at what that looks like, it looks like this. Look how flat the forehead is here. And you can see this baby board. And they're going to push the skull so that it looks like this. And here's another one over here. And if you look at what that looks like, it looks like this. Look at this person's skull. And if you look at it in a real skull or after they die, it looks like this. And so there are cultures that think this is attractive, and so they want their children to look like that. And so they bind the skull or they use these baby boards. So we wind up with skulls that look like this. Well, if you were to an archaeologist and you just dug up skulls like this and you didn't know that this was something that had happened in the human race, you might think these were aliens. But they're not aliens. So Maria says that's scary. Well, people do all sorts of body changes. Think about it. Lots of people pierce their ears. They do all sorts of other piercings. You see some African tribes, they stretch their lips. Some people stretch their earlobes so that they hang way down. We get tattoos. There's all sorts of body modifications that people do if they think those things are attractive. And so just because we don't necessarily think this is attractive doesn't mean that they don't. Now, you might think, well, does it do something to the brain? But the brain is actually very, very plastic. In other words, it's sort of like jelly. And just jelly, if you put the jelly in a jar, it's going to take the shape of the jar, no matter what that jar is. And that's exactly what the brain does. So the brain fits the cranium. So it does change the shape of the brain, but it doesn't change the function of it. But here's what a suture looks like in the adult. So look, these bones have now grown almost completely together. We have these interlocking things, but still there are these little tiny fibers holding those bones in place. Remember, there's no cavity, there's no space between these bones. So that's one type of fibrous joint. Another type of fibrous joint is called a syndesmosis. So if you look at a syndesmosis, we don't have very many of these joints. They're found between two parallel long bones. So you have one long bone here and another long bone here. They're parallel to each other. And there's a joint in between them. So they come close together, and there's a joint here. There's a joint here. And so you don't get a lot of movement, but you do get a little bit. So they're amphiarthrotic. Well, the best examples of this are in the lower leg, the tibia and the fibula, and in the lower arm, the radius and the ulna. So if we look at one of those, here's the tibia right here, and here's the fibula, and you can see that fibrous connective tissue holding these bones in place. And it looks like this. You can see the fibers. Sometimes this is called an interosseous membrane, but what it is a syndesmosis joint. Now, when we talk about in lab, we're going to see the hand and we're going to see the foot. Right here's the radius, and right here's the ulna. Right here's the tibia, and this is the fibula. And look, there's a joint between them right here, joint between them right here. And this orange colored stuff represents those fibrous connective tissues. So we have these fibers holding the bones in close proximity. Here's a real one. So you can see the cadaver foot here. And so if you look at this, now you can see those fibers right there, and here's the drawing of it. Same thing if you flip it around and look at it from the other side. You can see the fibers right here, holding the tibia right next to the fibula. And again, there's the drawing of it. So, this is a syndesmosis. Let's look at the last one, and this is called a gomphosis. Well, if you look at this word, if you look at the first three letters, gom sounds a little bit like gum. And this makes it an easy way to remember this, because where are your gums? They're where your teeth are. And this is where this joint is. It's between tooth and bone. Remember, the teeth sit in these little sockets called alveoli. Remember, we had an alveolar process on those bones, the maxilla and the mandible. So each tooth fits in a socket. Looks a little bit like this. There's the alveolar margin or alveolar process right here. And if you open it up, you can see that there's a tooth in a socket. It looks like this. So here's the tooth and here's the bone. Well, the tooth has this root which hangs down. And then attached to that root are fibers, and those fibers hold it against the bone. So they hold it in place. This is called the periodontal ligament or periodontal membrane. And it's a fibrous joint. There's no cavity, there's no space. If you look at it in X-ray, you can see these little fibers right here. And they're holding the root of the tooth in this socket. If you blow it up, it looks like that. And again, you can see these fibers. So this periodontal ligament, periodontal membrane is a fibrous joint. So those are the three types of fibrous joints. If you look at this picture, this is a child's skull. And remember, we have two sets of teeth. We have these baby teeth or milk teeth or primary teeth or deciduous teeth. That's these. Those are baby teeth. But these are the adult teeth, the permanent teeth that are forming in the jaw while the baby teeth are still present. And what happens is these adult teeth push the baby teeth out. And so the baby tooth, what happens is this joint right here breaks down. All those fibers break down. And when the fibers break down, there's nothing holding in the tooth in place anymore. And so the tooth comes out. You see, this person has already lost a couple of teeth. And here are the adult teeth that have pushed them forward. So, any questions about fibrous joints? Okay, let's look at cartilaginous joints. So cartilaginous, cartilage. Well, if you remember when we talked about the skeletal system, we said that there are cartilages associated with it. We have three types of cartilage. Do you remember? We have hyaline cartilage, we have fibrous cartilage, and we have elastic cartilage. But only two of these are part of the skeleton, and that's these two. And so what happens is hyaline cartilage is going to give us one kind of joint, and fibrous cartilage is going to give us the other kind of joint, because there are two types of cartilaginous joints. There's synchondroses. Remember, chondro means cartilage. And symphyses. So synchondroses, again, hyaline cartilage. So if it's hyaline, it has to be a synchondrosis. Symphysis is fibrous cartilage. So fibrous cartilage, remember, looks different, acts different than hyaline, and so these two types of joints are going to be different from each other as well. And so when you look at them, here is the cartilage right here. And this thing we talked about quite a bit. That's the epiphyseal plate. Remember we talked about the zones in it and all that, and this is the growth plate. Well, look, this is a joint between this part of the bone and this part of the bone. And that joint has hyaline cartilage in it. But if you look here, here's a vertebra and here's another vertebra, and there's fibrocartilage holding these in place. Remember, it's this intervertebral disc. And so we get very different joints depending on which kind of cartilage it is. Let's look at synchondroses first. So again, it's hyaline cartilage. It's usually like a bar or a plate. Well, these joints are completely immovable. They're synarthrotic, no movement whatsoever. And the best example of these is the epiphyseal plate, which we just looked at. And obviously, there's not going to be any movement right here. You're not going to have any because that's so tight. There's no cavity, no space. It's just this bar or plate of cartilage right here. And it's holding these two parts of the bone together. So when you look at that, you can see it very well. So there's our epiphyseal plates. That's that bar or plate of cartilage. This is a synchondrosis. Here's our actual epiphyseal plate, and we've seen this picture before. And you should actually still be able to look in here and pick out the zones. Hopefully everybody can do that. Remember, here's a resting zone. Here's the proliferating zone. Here's the hypertrophic zone. Here's the calcification zone and the ossification zone. You should be able to pick those out. But this is cartilage. And this cartilage is holding these bones together. So this is this synchondrosis joint. Let's look at a symphysis joint. So it's not hyaline, it's fibrous cartilage. So fibrous cartilage holds the bones together. But remember, when we look at fibrous cartilage, you can see the fibers. They're visible under a microscope. And those fibers are sort of spread out. They're big, they're thick, they're coarse, but they're spread out. And because they're spread out, we get a little bit of movement. And a little bit of movement is an amphiarthrotic joint. So symphyses are amphiarthrotic, whereas synchondroses are synarthrotic, no movement. But when we look at a symphysis joint, it looks like this. And look, that's a vertebra, and that's a vertebra, and that's a vertebra. So look, you can bend this way, and you can bend this way, and you can bend this way and this way. You can't bend much at each joint, but there's 26 of these joints. And so because there's so many of them, you get a little bit of movement at each one, a little bit, a little bit, a little bit. It makes the skeleton fairly movable because each one gives you a little movement. So again, they're amphiarthrotic. So there's the intervertebral disc between these two vertebrae. And then here, between the two pubic bones, is the pubic symphysis. So both of these are symphysis joints. So this is a symphysis joint, and this is a symphysis joint, because this is fibrocartilage, fibrous cartilage. And because it's fibrous cartilage, you're going to get a little bit of movement. So they're amphiarthrotic. Here's what that fibrocartilage looks like. So over here is bone, and over here is bone, and here's this cartilage right here holding these two bones together. Again, because it's fibrocartilage, because the fibers are spread out, we're going to get a little bit of movement. So it's going to be amphiarthrotic. So those are the cartilaginous joints. Any questions about either of those? Okay, well, the only joints we have left are synovial joints. And synovial joints are the most common type of joint in the body. In fact, if I were to ask you to name some joints, most of you would have named these types of joints. So this is joints like at the shoulder, the hip, the elbow, the ankle, the fingers, all of those are synovial joints. And when you look at them, there are 6 types of synovial joints. And the types are determined by the shape of the bones at the joint. So the shape of bones, because they have different shapes. And these shapes are going to determine what kind of movements we get. Well, every single synovial joint gives you a lot of movement. So all synovial joints are diarthrotic, and all diarthrotic joints are synovial. Sometimes those words are used interchangeably, but they don't really mean the same things. Remember, synovial means there's a joint cavity. Diarthrotic means you have a lot of movement. But it's the joint cavity, it's the space between the bones and the fact that the bones are not attached that gives you lots of movement. So when we look at this, we're going to see a joint cavity. And that cavity's got fluid in it. So there's a fluid-filled joint cavity. So if we look at one, they look like this. So look, here's a bone, and here's a bone. And look, there's a space here. There's a space, and in that space we have fluid. It's called synovial fluid. Well, when we look at these, they have certain characteristics about them. And so before we talk about individual types of synovial joints, let's just talk about one in general. So here's just a picture of a general synovial joint. And you can see lots of things. You can see this cavity, and remember, it's got fluid in it. But there are other things as well. There's a capsule that surrounds the joint, and that capsule protects the joint. It contains the synovial fluid. And when you look at it, it has 2 layers. So look, here's a bone here, and here's a bone. There's our joint cavity where the fluid is. And here's the joint capsule right here. So here's part of it here, and then it goes all the way around. So there's part of it over there too. Well, when you look at it, there are two layers to this joint cavity, and you can see both layers in this picture. So again, there's the bone, there's our bone, there's the joint cavity, and then we have this capsule. It's called the articular capsule, and again, it's got two layers. Well, in this picture, one layer is this one. It's sort of this gray layer. It's this one. And that layer is made out of dense, irregular connective tissue. But there's another layer facing the cavity, and it's this one right here. And that layer is the synovial membrane. So when you look at this joint capsule, it has two layers to it. It has a fibrous layer, that's the dense, irregular connective tissue. And then it has this synovial membrane, and that's actually simple squamous epithelium. Well, again, even here you can see two layers. Here's one layer, and here's one layer. You can see two layers. There's the fibrous layer, and there's the synovial membrane. And the synovial membrane actually secretes the synovial fluid. And so the fluid fills up this space, and it nourishes all of these joint parts. It's constantly being refreshed by this membrane. Synovial joints also have cartilage, but they're not cartilaginous joints because the cartilage does not hold the bones together. But they do have cartilage. That's what this is. So there's a cap of cartilage. It's hyaline cartilage. But look, they're not touching each other. There's a space. There's that cavity in between with that fluid in it. And so these two hyaline cartilage caps, if you will, the articular cartilage, they rub against each other. So when you bend this joint this way or you bend this joint this way, these are going to rub against each other. Well, if you had bone rubbing on bone, it would disintegrate. But remember, this is very, very tough, very, very resistant to wear. And so it protects the joint, protects the bones. So all synovial joints have this articular cartilage. Another thing all synovial joints have are ligaments. So ligaments are made out of dense, regular connective tissue. Remember, dense regular has collagen, and all the collagen fibers are parallel to each other. So a good way to think about a ligament is to think of it like a rope. And so there are these ropes here that are holding the bones close to each other. Here's one of those ropes right here. So look, it's attached to this bone, and it's attached to this bone. These bones are not that close to each other. But look, there's a rope holding them in close association. Ligaments can be inside the capsule. So here's our capsule over here. They can be inside like this. They can hold this bone together like this. And that's exactly what we see right there. But they could also be outside the capsule like this. And that's what we see right here. So they can be extracapsular, outside the capsule, or they can be intracapsular, inside the capsule. So this is an extracellular ligament, extracapsular ligament, and this is an intracapsular ligament. So if we look at this, you can see all those things. There's our joint cavity right there. That's this, but that's also this right here. That's the joint cavity. Again, it's got synovial fluid in it. And then here's our articular capsule right here. Remember, it goes all the way around. And it has two layers. Well, you can see the two layers in this picture. One of them is this layer. That's the fibrous layer. And one of them is this green layer. That's the synovial membrane. It's a little harder to see over here, but here's the capsule right here. We look in this picture, we can see the cavity, we can see the articular capsule, and then here's a ligament right here, this white or gray, light gray thing right here. That's a ligament. Look, it's outside the capsule because here's the capsule. So that's an extracapsular ligament. But there could be a ligament here, and that would be an intracapsular ligament. So all synovial joints have those things. Some synovial joints have some other things. Some have what are called bursae, some have what are called tendon sheaths, and some have what are called menisci. If you look at a bursa is basically a little sac full of synovial fluid. It's a little sac. And so when you look at it, that's a bursa right there. So it's very similar to the articular capsule. It has a fibrous layer on the outside, and then it has this synovial membrane on the inside, and the synovial membrane makes fluid, and so the space inside is full of fluid. So a little fluid containing sac. And what it does, look, it acts like a cushion. It acts like a cushion between two structures. It reduces friction. So when you move your arm, when you move your shoulder, when you move your knee, there's friction that happens. But there are these little bursae in here that actually roll back and forth as you move. And as they roll, they reduce friction. They act like little tiny ball bearings almost. So some synovial joints have bursae. So again, there are these flattened fibrous sacs lined with a synovial membrane, and they have synovial fluid on the inside. Again, they're there to reduce friction. Some synovial joints have tendon sheaths. So a tendon sheath is the same thing as a bursa, except that a tendon sheath is elongated. It's an elongated bursa. And inside that is a tendon. And a good way to think about this is think about a hot dog bun. So here's a hot dog bun. And then there's a hot dog inside it. So here's the hot dog. The hot dog is like the tendon, and the bun is like the tendon sheath. So if you look at it, here is a tendon sheath, right here. And look, there's a tendon right there, like the hot dog. And then wrapped around it like this is this elongated bursa. So it's almost identical, except it's very long, and then it's wrapped around the tendon. So here's a tendon. It looks like this. It's wrapped around it like that, and it's very long. So here is a bursa, and here is a tendon sheath. Does it make sense? They're almost identical except for the way they look. And then one other thing that some synovial joints have, and that's menisci. So a meniscus is like a shock-absorbing pad. So think about this. If you sat in a chair all day long, working at a computer or something for hours and hours and hours, your rear end might get sore. After a while, you get tired of sitting in that chair. But if you are smart, and instead of just sitting on the hard chair, you get a cushion, a pillow of some kind. When you sit on that, it's going to absorb the shock. It's going to cushion your rear end. And so you're going to be less sore. And then think about if instead of just sitting there, you bounced up and down in your chair, bounced up and down, hours upon hours. Well, if it's this hard chair, it's really going to hurt after a while. But this cushion in here will absorb the shock and protect your rear end. And that's exactly what menisci do. They absorb shock. So here's a bone, and here's another bone, and then you have this cushion in between. And this cushion keeps the bones from banging into each other when you jump up and down or when you run or anything like that. So when you look at a meniscus, they look like this. So here's a meniscus right here, these sort of C-shaped or semi-lunar shaped pads. This is in the knee. So think about how much pressure is put on your knees. If you jump up and down, if you run, your weight, whatever it is, 200 pounds, 100 pounds, whatever it is, plus acceleration is banging this bone into this bone. And if those menisci weren't in there, these bones would collide and you'd get a lot of damage. So they're in there to absorb shock and protect the bones at the joint. So those are some things that some synovial joints have. Bursae, tendon sheaths, menisci. So we looked at a bursa and a tendon sheath. Remember, this is a bursa here. This is the elbow, by the way. And so you have a bursa on the tip of your elbow. And there's a tendon sheath right there. We also have bursae between bones. So if you look at this, this is your foot. And so you can see your big toe all the way to your little toe. Well, look, between each two toes, there's a bursa there to keep these bones from banging into each other. They're shock absorbing and friction reducing. And then we have tendon sheaths. And remember, it looks a little bit like a hot dog and a bun. But all it is this elongated bursa to protect the tendon and reduce friction. And then again, we looked at these menisci. The knee has two of these. Okay, now that we know what a typical synovial joint looks like, let's look at the individual types. And remember, there's 6 types. There's gliding joints, which are also called plane joints. They're hinge joints. They're pivot, which are also called rotational joints. There are ellipsoid, which are also called condyloid. And then there's saddle, and then finally ball and socket. And remember, what's going to determine which type of joint it is the shape of the bones at the joint. The shape of the bones at the joint. And so we'll see that. So again, 6 types. Let's look at these 3 first: gliding, hinge, and pivot. So before we actually look at the joints, let's look at the bone shapes. So if you look at a gliding joint, look, the bones look like this. They're flat against flat, flat on flat. But if you look at a hinge joint, look, it doesn't look like that at all. It's sort of a cylinder in a trough. And if you look at a pivot joint, it's got this cone sort of in a sleeve. And so it's going to determine the types of movements that we can get. Well, we haven't talked about movements yet, but you can describe movements by which way they go geometrically. So if you remember geometry, we have an axis. There's an x-axis, a y-axis, and then there's a z-axis. And so you can make movements along one of these, 2 of these, or more than 2 of these. So we can have uniaxial or monoaxial, and then we can have biaxial, and so on. So let's look at these different types of joints. Let's look at the gliding joint first. So gliding joints, flat on flat, flat against flat. A good way to imagine this is to think of a book on a table. So if you put a book on a table and then just slide it around, you can slide it any way you want it to go. Now you can't lift the book up, you can only slide it around. That's exactly what is this. They slide around on each other. Like if you were to put your socks on and slide on a linoleum floor, not picking your feet up, just sliding around. Well, you can slide in any direction. The best examples of this are here, which are between the carpal bones in the wrist, but also between the tarsal bones in the ankle. So these bones have flat surfaces that slide around on each other. Flat on flat. And what we get is either non-axial, in other words, no axis at all, or sometimes they're called multi-axial, which means lots of axes. And you can see that here. And so some examples of these are these over here. And so the ones I mentioned are these. But there are also joints between the vertebrae, the sacroiliac joints, between the acromion and the clavicle, and between the clavicle and the sternum. Those are all gliding joints. Let's look at the hinge joint. So a hinge joint, again, different shape. Here we have a cylinder shape in kind of a trough. And what we get is sort of a swinging movement, kind of like the way a door opens and closes. So if you think about a door, it's got hinges on it. And the only thing a door can do is swing in or swing out. That's it. That's all it can do. In other words, that's one axis it's moving on. It's moving this way and this way on that one axis. Or it could be moving this way and this way, only on that one axis. And so these are uniaxial joints. The best example of this is the elbow. So here's the humerus, and there's the ulna. If you remember, this is the trochlea, and this is the trochlear notch. And that fits in there, and it gives you this swinging movement. So if you do that with your elbow, hold your arm still, but bend your elbow, straighten your elbow, bend your elbow, straighten your elbow. It only moves in this one plane. There's some other hinge joints, the elbow, but also the knee, the ankle, also the joints between your phalanges and your fingers. Let's look at a pivot joint. So a pivot joint is when you have this sort of protrusion of bone, this sort of cone shape inside a sleeve. A cone inside a sleeve. What the movements that you get are spinning movements. It spins back and forth. So if you shake your head no, you shake your head no, you turn your head this way and then you turn your head this way, it's sort of spinning a little bit on the first vertebra, or second vertebra rather. Another place you can find this is at the elbow. It's not the elbow joint though, it's between the radius and the ulna, at the elbow. And so if you turn your palm up or you turn your palm down, this is going to spin as you turn your palm up or turn your palm down. There's our sleeve, there's our cone right there. So we have a cone and a sleeve, and you get sort of a spinning movement. It's only in one axis, so it's uniaxial. Any questions about any of these three? Okay, let's look at these three then. So this is the condyloid, which is also called ellipsoid, the saddle, and the ball and socket. So before we talk about these, let's look at these bone shapes. So if you look at a condyloid or ellipsoid, they're oval shaped. So that bone is oval, and so is this one. One is oval concave, and one is oval convex. And so you have this oval convex that fits in an oval concave. If you look at a saddle joint, look, it looks like a little cowboy or somebody riding a saddle, riding a horse. So here's the saddle and here's the little cowboy. And it fits like that, just like a man sitting on a saddle. And then if you look at a ball and socket, this is the easiest one to imagine because it's a ball in a socket. So let's look at these. So let's look at condyloid or ellipsoidal. So again, they're oval. Both surfaces are oval. And when you look at it, you can see there is the oval convex and there is the oval concave. Well, if you look at an oval is shaped like this. And because of this shape, when it moves, you get movements in two directions. But one direction is wider than the other. You get bigger movement in one direction and smaller movement in another. But there's two directions, so it's biaxial. So a good example of this is at the wrist. Think about your wrist. Your wrist can bend. So here's your wrist right here. And this is your fist. Your fist can bend this way, but it can also bend side to side, but not as much. So front, forward, and backwards it bends a lot, but side to side it only bends a little bit. And that's because of this oval shape. Another example of this is between the finger and the hand. So this joint right here where your fingers meet your palm of your hand, your fingers can bend two directions. So if you look at your fingers, they can bend forward and backward a lot, but side to side only a little bit. They can only bend this way a little bit, but they can fold completely down into a fist. And so they can move a lot that way. But again, oval concave and oval convex. So we get two movements, but one is bigger than the other. Let's look at a ball and socket joint. So remember, this is like a little man sitting on a saddle. So there's the little man, and there's the saddle right there. And look, both surfaces have a convex and a concave. Both surfaces have a convex and a concave. So because of that, we get movements in more directions. Actually, not more directions, but bigger movements in each direction. So we still only have two directions, but they're bigger movements. Humans only have one saddle joint in their whole body, and that's right here. It's at the thumb. So where your thumb attaches to your hand, right there is a saddle joint. And so your thumb can move a lot bigger movements than the rest of your fingers. It's still biaxial, but you get big movements in both directions. Not one big one, one little one. You get big ones in each direction. So, looks like this. So here's the little man, and there's the saddle. Again, we only have one of these, and that's at the thumb. That's a really important joint because it lets us grip things. In fact, this joint is what defines primates. No other animals have thumbs except primates. So monkeys do, apes do, humans do, but no other animals do. Just primates. And then the last one is this ball and socket. And again, it's really easy to picture because it's a ball and a socket and a cup. We only have two of these joints. One is the shoulder and one is the hip. And think about the movements your shoulder can make. It can do all kinds of things. It can spin, it can lift, it can go down, it can fold forward, it can do all kinds of things. And so it can move in lots and lots and lots of directions. And so it's a multi-axial joint. A ball and a cup and a socket. And again, multi-axial. Any questions about those? So those are the 6 types of synovial joints. So remember, there were some characteristics that all of these had. Remember, they all have a cavity. They all have an articular capsule with 2 layers. They all have synovial fluid. They all have articular cartilage on the ends of the bones. And then remember, some of these, not all of them, but some of them have bursae, some have tendon sheaths, and some have menisci. So we looked at these, we looked at these, and we looked at these. Any questions about any of those? Those are all of the types of joints. Okay, well, remember that joints have 2 functions. One is to give our skeleton mobility, but the other is to hold the skeleton together. In other words, provide stability. But these 2 things are opposites. They're opposites. And so if you gain in one, you're going to lose in the other. So the more stable a joint is, the less mobile it is. And the more mobile it is, the less stable it is. Look, if we look at two joints of the same type, we can see this. If we look at the hip versus the shoulder is very, very mobile. And look at the shape up here. The cup is this tiny little thing right here. There's the ball. It's a half ball right there. But look how loose this joint looks. Look at all of this space in here. These bones hardly touch each other at all. And so we have a high degree of mobility. But think about this. How often do people dislocate their shoulders? It happens a lot. Every single day in hospitals all over this country, people come in with dislocated shoulders. It can dislocate this way, it can dislocate this way, it can dislocate this way. It can dislocate in lots of directions because it's a very, very loose joint. Well, that loose joint is not very stable. It's easy to damage this joint, but it has a high degree of mobility. But if you look at the hip is exactly the opposite. Look how deep this cup is. Remember, that's the acetabulum. And that head fits in that cup deep in there. Over 50% of the head is covered by this cup. My mouse is doing something weird. Here we go. Look, over 50% fits in the socket. And then we have this joint capsule with an extensions on it. And so in other words, there's connective tissue that sticks out the cup even deeper. And then we have very, very, very strong ligaments here. So if you think about the hip is very, very stable. Lots of stability. But can you move your hip the same way that you can move your shoulder? Can you move it like the shoulder? There's no way. And so because it's so stable, the bones are so tightly held close to each other, and the ligaments and stuff are so strong, we have decreased mobility. So again, these things are opposite. Stability and mobility are opposite. If you get one, you lose the other. If you gain this one, you lose this one. So the more stable a joint is, the less mobile it is. And the more mobile it is, the less stable it is. Well, what determines how mobile and stable joints are the shapes of the bones and then the strength and the tightness of the ligaments. Any questions about that? Well, one of the things I might ask you to do is I might ask you to name some of these joints. So look, I might ask you to fill this table out. So number one is name as many joints as you can that are both fibrous and synarthrotic. Remember, fibrous means that they're fibers holding the bones together. Synarthrotic means no movement whatsoever. They're immovable. So a good example of that is the adult suture. That is a synarthrotic joint. And so I might ask you to do that for each one of these. So, are there any synovial joints that are synarthrotic? Anybody want to guess? Are there any synovial joints that are just synarthrotic? There are none. So if you fill this table out, it should look something like this. So look, when you look at the table, a synchondrosis is both cartilaginous and synarthrotic. Remember, Synovial joints, all synovial joints are diarthrotic, and all diarthrotic joints are synovial. Does it make sense to everyone? Okay, I want to stop there and take a short break, and we'll come back in about 15 minutes. So let's come back at 20 after.